locate the epicenter of an earthquake from today's assignment, and it's locating the epicenter number 3. I'm going to focus on the March 17th earthquake. So if you open that up and take a look at that, I'm going to first find out the time difference, the arrival time difference of the P wave and the S wave. So if you turn to the March 17th, make sure you're looking at the right seismograms. I'm going to start with the Seattle, and just once again pay attention that these are 30-second increments. So each tally mark or tick mark is a 30-second period of time. So the arrival time of the P wave is right here. So that would be 30 seconds, a minute 30, 2, and since this was a little bit over that hash mark and this is a little bit over, I'm going to call it 2 minutes. So go back to Seattle, and that is 2 minutes. Now I'm going to look at Denver. Denver, the arrival time is 1 minute, 2 minutes, and 30 seconds. And Houston, the arrival time goes 1 minute, 2 minutes, 3 minutes, and 3 minutes 30 seconds, 3 minutes and 45 seconds, I would say, is a pretty good estimate. 3 minutes, 45 seconds. Okay, once I do that, I have to take these amounts, and using a sheet of paper, like you've done in class several times, I have to go to the, what do you call this, the graph that shows the distance from the epicenter and the time travel. Since I know the time travel was 2 minutes for Seattle, I go ahead and mark 2 minutes on my graph, and again, keeping this paper perfectly vertical and keeping this edge on the P wave line, and I want to move this up until the top mark that I made at 2 minutes hits the S wave line, and it does right at that point. And once it does, I go directly down, and that is 1,200 kilometers. So going back to this page again, 1,200 kilometers. Do the same thing for Denver, 2 minutes 30 seconds. Use a different mark this time. I'm going to use that mark for my starting point. 1, 2, and then 30 seconds is halfway between, so you want to be as accurate as possible. Moving that up, looks like 1,600 kilometers. Okay, and last 3 minutes and 45 seconds. There's another mark for that. 1, 2, 3, 45 would be about right there. Okay, and again slide it up until they meet. Looks like it's about right there, which would be 2,200 kilometers. All right, so then the last step, you take all these measurements, 1,200 kilometers, and we go to our map. And our first one was from, first one was from Seattle, and then Denver, then Houston. So Seattle, 1,200 kilometers. I take my protractor, mine's a little different than yours, but I go to 0 and 1,200, and I'm going to draw a circle from Seattle at 1,200. And I don't have to draw it all the way, I just want to keep it on my map. Okay? Then I go to my next one, which is Denver, 1,600. Go back to my scale here. 1,000, 1, 2, 3, 4, 5, 600. Go to Denver, and these should definitely cross, and they do. So right now we can narrow it down to either that location or that location for the epicenter, but we need a third seismogram, and the third one is from Houston at 2,200 kilometers away from the epicenter. 2,200. So I go to 0, and our graph only goes to 2,000, so I kind of extended it a little bit, if you can see there. So 2,200 would be approximately right there. And this should be from Houston. And it looks like, boy, that doesn't look very close, does it? Looks like it's not very close. So either I made not a very accurate measurement, or somewhere I made an error. But anyways, where the 3 triangulate is where the epicenter of the earthquake is. So you want to do each one of these earthquakes in a different color, and so that you're going to have 9 different circles on this map. So you want the 3 from one event to be in one color, 3 from another event to be in another color, and 3 from the third event to be the third color. So hopefully that's helpful. If you have any questions, make sure you ask questions.